Okay, so in today's video we're going to have a look at similar shapes. So grab a piece of paper, grab a pen, make some notes. We've got a few different types of questions to have a look at. Now this says, in this question, E, F, G, H and A, B, C, D are mathematically similar. Just to talk about that very quickly, E, F, G, H goes from E to F to G to H around this shape and forms a shape on the left. So it's just a way of describing that shape there on the left, likewise with the A, B, C, D. And it says they're mathematically similar, and it wants us to calculate some lengths. So we're going to find the length BC, and we're also going to find the length FE. Now BC is over here, B to C, and the other one there, F to E, is this one over here, this little one. Okay, so they're lengths we're going to be actually finding, but let's just talk about what mathematically similar means at the moment. Now that word there, mathematically similar, means that one is an enlargement of the other. So they're exactly the same shape, only that one has been enlarged, so the angles are the same on the inside, but the side lengths are all bigger by a certain scale factor, and that's the important word there, scale factor. When there's an enlargement of a shape, we need to find the scale factor between them. So in order to find the scale factor, we have to identify some common lengths on these two shapes. Now we've been given lots of lengths. We've got the 8 centimetres on the left there, the 7.5 on the right, and then we've got these two lengths down the bottom. Now those two lengths down the bottom there are matched between the two shapes. So in order to find the scale factor between the two, I'm just going to look at those two, the 6 and the 9. So in order to find that, I'm just going to take the big length from the big shape and I'm going to divide it by the little length there on the smaller shape. So the sum that I'm going to do to find the scale factor is 9, and I'm going to divide it by 6. And doing that on the calculator, 9 divided by 6 gives us 1.5, and that is the scale factor between the two, and that's absolutely key that we find that scale factor. Now if we didn't have a calculator, we might just have to take a slightly different approach, because it could be a non-calculator question, in which case what I would do is I'd look at this fraction here, 9 over 6, and I'd simplify it. Now the top and the bottom divide by 3, so that would give me 3 over 2, which can then be converted into a mixed number, or hopefully you know that half of 3 is 1.5, or you could write it as 1.5, 1 and 1/2. Okay, either way, we've got a method there for thinking about the scale factor if we do or don't have a calculator. Sometimes they'll be quite nasty decimals and they'll be quite clearly calculator questions, but this could potentially be a non-calculator question here where you just have to simplify the fraction. So a couple of things to be thinking about there. Now when it comes to finding the length, we're either going to divide or times by that scale factor. Now let's do the first one to start with, the length of BC. Now that length BC that I've highlighted there in yellow is the same as this 8 centimetre length right here. So we're going from the smaller shape up to the bigger shape. And think logically, if we were to divide by 1.5, we'd get a smaller number. And if I work that out on my calculator, 8 divided by 1.5 gives me 5.3 recurring. So we know that that's not going to be the way that we're going to do this. Now what we're going to do, when we're going from the smaller to the bigger shape, we're going to just multiply by that scale factor, so times it by 1.5. And again, if this is a calculator question, nice and easy, type it in, we get 12 centimetres. If not, you may just have to multiply by that scale factor. Now 1.5 is quite a common one, and if you think logically about what that means, it times it by 1 and the additional half, so actually it just adds half back on. Half of 8 is 4, and if you add that on to 8 you get the 12 there. So it's just ways that you can do. Obviously you can do your multiplying decimals, so 8 times 1.5 if you didn't have a calculator. Moving on to the other one, we've also got to find the length FE, and that's matched up with this length here, 7.5. So to get from 7.5 down to the smaller length, this is where we are going to divide by the scale factor. So on your calculator, we're going to type in 7.5 divided by 1.5, being careful not to do it the other way around. Don't do 1.5 divided by 7.5, otherwise we're definitely going to get a very, very small length there. But 7.5 divided by 1.5 gives us the answer 5. So 5 centimetres would be the length of F to E there. Okay, so two different things that we can do. We can times or divide by the scale factor. We just need to remember, take the big length, divide it by the little length to get our scale factor, which we've got up here as 1.5, and then times or divide depending on whether we're going to the bigger length or down to the smaller length. But let's have a look at another question. Okay, so we're going to follow the same process on this question. It says that these two are mathematically similar. Those words there are very important. They are mathematically similar. And then we're going to calculate two lengths again. We've got A to B and Q to R. Now, first things first, before we even think about that, we need to get the scale factor. So the two lengths that are matched up here are the 4 and the 6 down there. And if we do 6 divided by 4, the big divided by the little one, 6 divided by 4, and it again gives us 1.5. Again, you can think about simplifying that as a fraction. Look, dividing the top and bottom by 2 gives us 3 over 2, which again gives us 1.5 or 1.5 as our scale factor. And make that really nice and clear that you found the scale factor there and show that working out. Now let's have a look at this first one, AB. So AB is this length over here, so one of the smaller lengths, and that's matched up with the 15. So we're going to go down to the smaller length, so we're going to divide by the scale factor. So 15 divided by 1.5, and that gives us 10 centimetres for our smaller length there. Going on to the other length that it's asking for, Q to R, that is over here on the right hand side, and that's going from the 12 that it's matched up with there. So we're going up to the bigger length, so we're going to do 12 and multiply that by the 1.5, and adding on an extra half there adds on an extra 6, so that'll be 18 centimetres. There we go, and there's our two answers. We've got 10 centimetres for the length AB and 18 centimetres there for the length Q to R. Okay, so 2 steps: find your scale factor, big divided by little, and then the second step is going to be to times or divide by that scale factor to get to a smaller or a larger length. Just make sure you match them up carefully with those similar sides. Okay, here's some for you to have a go at. Okay, so here's 2 questions, one on the left, one on the right, both are mathematically similar in each case. So have a go at these, pause the video there, and we'll go over the answers in a sec. Okay, so the first one. Now the sum we need to do, look, we've got 6 and 4 there that we've got matched up. So 6 divided by 4, again, gives us that scale factor of 1.5. You'll see it's quite a common scale factor that comes up. So 1.5 is our scale factor. Now to find the length of BC, which is the first one it's asked for, we need to get this length here, which is matched up with the 10.5. So to go from 10.5 down to there, we're going to divide by 1.5. So 10.5 divided by 1.5 gives us the answer 7 centimetres for our first part there. Then we've got the next part, which is D to F, which is this one here, and that's linked up with the 9 centimetres, so we're going to times by 1.5 to get that to there. So times by 1.5, and that gives us the answer 13.5 centimetres for that one there. So there's our first 2 answers, 7 centimetres and 13.5. On to the next one. Finding our similar lengths here, we've got 10 and we've got 6. So 10 divided by 6, and this doesn't give us the nicest of scale factors, it gives us 1.6 recurring. Now here's something very key to do in this question. So we've got our scale factor, just like we've got the 1.5 over here, we've got the 1.6 recurring over here. Now for the first one, it wants us to find the length of B to C. So for B to C, which is this length here, I'm going to have to make sure I multiply this 12, which is the similar side on the smaller shape, by the 1.6 recurring. Now we've got to be very careful, so a little bit of a calculator trick here. If I want to times by 1.6 recurring, I definitely don't want to just times by 1.6. I need to make sure that I actually use that recurring 6 there. Now what I would suggest is keeping that 1.6 on your calculator display. Now all I have to do on my calculator without clearing anything is to press 12 times and then use the answer button, which is usually right next to the equal sign. If I press 12 times answer, it gives me the answer 20. Now if you did round that, you're not going to have got the answer 20 there. So it's something to be thinking about, making sure that you actually use the 1.6 recurring. Now some calculators do allow you to type the recurring decimal back in yourself. Not all of them do though, so it's probably best just to leave the 1.6 in the calculator and then just press 12 times answer, the 8NS button, and that's going to really help just to make sure that you don't get any rounding errors here. Now we're going to do the same again for the next part. So what I'm going to do is I'm going to type in 10 divided by 6 again, just to make sure that my calculator has the 1.6 here back on the answer button that I can use. Otherwise it's going to have had that 20 centimetres in there. I don't want to use 20. So linking this up then, we're trying to find the length of PR, which is over here, which means I'm going to go from the 18 down to that length there, which means I'm going to divide by this 1.6 recurring. Okay, so again on my calculator I'm going to type in 18 divided by answer, and that gives me 10.8 centimetres, so 10.8 centimetres, and that's our second and final answer for this question. Okay, let's have a look at something slightly different then. Okay, so this question says triangles ABC and ADE are mathematically similar. Let's have a look at that. ABC is this triangle here sitting on the top, and then it also says that's similar to ADE, the larger triangle that we can see around the outside. So what's actually happening here is the triangle is within or inside the other one. Now when it comes to a question like this, and you don't have to do this, but I would say if you're struggling to see the two triangles separately, just redraw them both, and they don't have to be perfect. Look, all we're going to do is draw one slightly bigger and one slightly smaller, and they're by no means perfect. So this one here is A, B and C, the smaller one, and the larger one is A, and then we've got D and we've got E. And we'll just need to make sure that I put those side lengths on it as well, just to make sure it's nicely labelled. So we've got the 12.5 down the bottom of the smaller one, 12.5. And then we've got 15 on the side of that. I just need to be careful for the last bit, because for the last bit we've got the full length here of A to E. So it's the combination of the 15 and the 6 there, so that makes 21 on the length of that larger triangle. So 21, the 15 and the 6. Now you might be able to see it slightly clearer, because now we've just got two shapes just like the previous questions. So in order to get the scale factor this time, we just need to obviously compare this 21 and this 15, just obviously making sure that we are very careful when we're doing this, we do get that combined length. So 21 divided by 15, and that does simplify, but if we've got a calculator, 21 over 15 gives us 1.4 as our scale factor. And that's obviously our key number in this question. And it says to calculate the length of D to E, which is quite nice and easy now. We just need to get this length down the bottom. So we're going from the smaller to the bigger one. So we're just going to times by 1.4, which is our scale factor. And 12.5 times 1.4 gives us the answer 17.5 centimetres. There we go, so our final answer there is 17.5 centimetres. So have a look at something which is slightly trickier, but in a very similar fashion to this question. Okay, so this question doesn't say that the shapes are mathematically similar, but what it does say is that BE, the length BE and CD are parallel, and that's these two lengths here, BE and CD, shown there by those parallel line symbols. Now, as it says that they're parallel and the shapes are within each other, they must be similar, because the angle at the top here, angle A here, or CAD, whichever you want to call it, that angle there has to be the same in both triangles. Likewise, because the angles, this line BE and CD are parallel, we've got parallel line rules going in, meaning that this angle here and this angle here are corresponding, and therefore they're equal. And let's do that in a different colour, but this angle here and this angle here, they have to be exactly the same as their corresponding angles, thinking about parallel line rules. Likewise, we also have these two angles here and this one there that are also corresponding following our parallel line rules, so all the angles are exactly the same. That means that these two triangles must be mathematically similar. Okay, so when we've got these parallel lines going in, it won't say they're mathematically similar, but because of our parallel line rules, they are. So if we think about how we're going to approach this question now, we just need to think what it's actually asking for as well. It does say calculate the length of E to D, which is a bit of a different one here. It's this little length on the side, E to D. So just got to be very careful with this question, because that's not actually a length of either of these triangles, the little one on the top or the big one. It's part of the length of the big one. So if we do the same approach again and we just redraw these two triangles, we've got the little one on top and the bigger one there around the outside. And again, by no means a perfect drawing. So the little one there, we've got the length of 9 here, and we've got the length of 6, again, just getting that from here and here. Then we need to get the lengths of the larger triangle, and again, they are a combination of lengths. So to get the length of the larger, I'm going to use the 9 and the 3 there, and 9 and 3 added together make 12, so this length is 12. And I've got the length 7 down there on the bottom of the larger triangle, so I can just write that length in. Now we've got all the information from the diagram, we just need to think about how we're going to find the length E to D. Now E to D, if I draw it on my little drawing, this is just part of this little triangle here. It's the difference between the 6 and the full length. So in order to get this little length here, I need to find out what the full length is. So I'm just going to forget about that little piece for the moment. I'm going to find the full length of that triangle. So to find the full length, we just need to get the scale factor. So again, we've got to identify the two common sides, and that being the 12 and the 9. And 12 divided by 9, or 12 over 9, gives us a scale factor. Let's type that in. 12 over 9 are 4/3. Again, gives us this recurring decimal scenario, which you will get sometimes, 1.3 recurring. So this is definitely a calculator question. So to get to that full length, nice and easy from here, it's the same approach. We're going to go from the 6, and we're going to multiply it to get to the bigger one by 1.3 recurring. So I'm going to take that same approach. I'm just going to type in 6 times answer, or 6 times ANS, and that gives me the answer 8 centimetres. So if this full length here is 8 centimetres, we know that part of it is 6, and therefore the gap between them must be 2 centimetres. So E to D, let's write that as ED, equals 2 centimetres, the difference between 6 and 8. Now I'm going to give you another question now, which is very similar to this one in terms of trying to find a little part or a little piece of one of the sides. So here's that question. So see if you can work out this question. It's very, very similar to the one before. So just pause the video there, have a go, and we'll go over the answers in a sec. Okay, so for the answers for this one. Now, looking at these two triangles, if I was to redraw them again, we've got a little triangle on the top and the large triangle around the outside. And if we label that up, we've got 4 here and we've got 4.8 here. And on the larger triangle, the combination of the 6 and the 4 makes 10. And we haven't got the right hand side, we haven't got the bottom. I've just noticed actually we do have the 5 on the little triangle there. There we go. Now, in order to get the scale factor here, we'll match up the 4 and the 10. So 10 divided by 4 gives us a scale factor of 2.5. So that's our scale factor. Now the first part of the question says work out the length e to d, which is the same as our little example that we just did there. E to d is the gap between the small and the large one on this right hand side. So to get to that one, I'm going to times 4.8 by my scale factor to get the full length here. And let's write that in, times 2.5. And 4.8 times 2.5 is 12. So that full length there is 12 centimetres. So in order to get from 4.8 to 12 centimetres, I can do the sum. I can just do 12, take away 4.8, and that's going to tell me the difference between them. So 12 take away 4.8 equals 7.2 centimetres, and there's our first answer. Now there's an additional little part in this question which also said to work out the length of CD, and CD is down here, the length of the bottom, which is hopefully quite nice and easy. Now you've got the scale factor because we're going from the 5 down here to the big length. So again, we're just going to times by the scale factor, so times 2.5, and 5 times 2.5 is 12.5 centimetres. And there we go, there was the second part of this question, 12.5 centimetres. Obviously that first part there, finding the little length e to d, was the harder bit there, so 7.2 centimetres for e to d and 12.5 centimetres for the full length. Now I'll go have a look at one more type of question before we finish, so let's go and have a look at that. Okay, so this question says AB is parallel to XY, calculate the length of PB. And again, we can see that we've got our parallel line symbols here and here. Now, again, just thinking about this and as to why these are going to be mathematically similar, well, if we have a look, we've got some vertically opposite angles here and here around the P. So 2 of the angles in these triangles are identical. Now, looking at the other ones, how are we going to show that they are also identical? Because all the angles have to be the same if they are mathematically similar. Now, if I start with this angle here sitting by the A, thinking about our parallel line rules, we've got an alternate angle down here by the Y, okay, making that Z shape if you've been learning your parallel lines like that, okay. If I draw that in, look, we've got an alternate angle hooking in those 2 pink dots there that I've drawn in. Likewise with that, we've also got an alternate angle next to the B here and next to the X up here, so they are also alternate. So all of the angles within these triangles are the same, therefore they must be mathematically similar. So we can apply exactly the same rules here, but if we're going to redraw these, which we can do, we just have to think carefully, because obviously the top angle here over by A is the same as the bottom angle over here. So it's almost like if we chop these 2 triangles off, if I chop them off here, if I was able to do that, the little triangle on the left there would have to rotate 180 degrees round in order to match. And if I do that, if I just take this little triangle here on the left and I draw it the other way round over here, and let's recolour in these little dots, the B would be there. Let's have a look, I'll try and use all these colours here. The A would be down here, and then my yellow one by the P would be just here. So if I just label them to the side, look, we've got our 6 centimetres here. This is where the P is, the A has gone down here, and the B has gone up there, so I've just rotated it around 180 degrees. Essentially, this side here is linked with this side here, okay, so these 2 are linked, and also the other way round for those other sides, so this side here is linked to this side here, so it's a little bit strange because it's been flipped over on the top there, okay, so, but they are the sides that are linked. I'm going to get rid of all that because I've drawn over that quite a lot, and I don't want to make it look too confusing, so let's get rid of all of that. There we go, but that is our question there. So I'm now looking at the big triangle there and my little triangle that I've drawn. Now we have one matched side, look, that's the 15 and the 6. So I can get my scale factor, I can do 15 divided by 6. There we go, and 15 divided by 6 gives us a scale factor of 2.5 again. It keeps coming up as well, so 2.5. Now it wants me to work out the length of P to B, which if highlight that on my little triangle on the right, and I'm kind of running out of highlighter colours here. Let's go with this one. So from P to B is this side here, and that is linked to the 12.5. And again, now we're going from the big one down to the smaller one, so we're going to divide that by 2.5, and 12.5 divided by 5, divided by 12.5, 2.5 is 5. There we go, I was doing the answer there in my head. So 12.5 divided by our 2.5 scale factor gives us our answer of 5 centimetres. So again, you can redraw this one if you like, if it helps you to see it, but you've just got to remember when it's attached on the top there, you've just got to rotate it around. Okay, but here's one for you to have a go at that's very similar. Okay, so here it is, the last question you're going to have a go at. It says DE is parallel to AB. Calculate the length of CE and BC. Okay, so CE being this one here. And if we highlight the other one, BC being this one here. Okay, so they're the two that you're going to have a look at. I'm just going to get rid of those. Okay, but there's your question. Have a go. Pause the video there. We'll go over the answers in a sec. Okay, here we go. So if I redraw this little triangle on the top here, let's imagine it's chopped off. So I'm going to redraw my ABC. So I'm going to flip that over. So C's there where it's cut off. B's going to rotate round to here, and A has gone to here. Now that length between A and B is 6 centimetres, so let's draw that in. And that length between A and C is 8 centimetres there. So now I just want to see which two are matched. So let's have a look. We've got the 9 and we've got the 6 there that are matched. So in order to do our little scale factor, we're going to have to do 9 divided by 6. And 9 divided by 6, which has come up a few times, gives us a scale factor of 1.5, so no nasty decimals here, which is quite nice. Now, let's have a look at finishing this off then. So C to E is what we're looking for, which is this length here, and that's paired up with the 8 centimetres there. So 8 centimetres, we can times that, because we're going up to the bigger one, by 1.5, and 8 times 1.5 gives us 12 centimetres. So there's our first answer, 12 centimetres for C to E. The last one it wants us to find is B to C, which is this little length here, and let's just swap colours. So we're going to find this one here, B to C, and that's linked up or paired up with this 13.5. And again, we're going from the bigger one down to the smaller one to get to there. So we're going to divide by the scale factor. So divide by 1.5, and 13.5 divided by 1.5 gives us the answer 9 centimetres. And there we go, and that finishes that question off there. Hopefully you'll see there's a lot of similarity between all those questions, just some slightly different approaches as how you can tackle some of these questions when they're drawn slightly differently. But that's the end of Similar Shapes. Hopefully if you found that useful, if you found it helpful, please like, please comment, please subscribe, and I'll see you for the next one.